Howdy, y'all. I think I'm live. Please let me know in the comment section. I'm having a little bit of trouble with OBS. On my end, it is buffering something awful. I have about 5 frames per second, 6 frames per second. Not entirely certain why, but hopefully it's clear enough on your end. Hopefully at least the sound is clear enough on your end. Howdy, Shirley, Ian, Lord Emperor. So yeah, we'll see how this goes. Again, like I said, it looks to me like I'm buffering, and it has already crashed once. So you'll have to take it for what it is. I'm wondering if my MacBook just doesn't have the RAM or the juice to actually pull this off. I've closed out most of my programs, so I don't know. Maybe it's Google. I have no idea. Anyway, howdy. I am Professor Parks, PhD, and I make content on astronomy, mental health, and science skepticism, but not necessarily in that order. Today, we're going to be talking about a book that was published, I think, in 2022. Let me see here. If I can find the author. Author's name. It's not on the title page, oddly enough. Simon Shack, and it was published in 2023. And so I did a stream on part of this book a while back ago. And I've lost the chat, so let me bring that back up again. So, a few weeks back or so, I did a review on the 31st chapter of this book, where he points out 41 anomalies that the TYCHOS model fixes. And I'll talk about what the TYCHOS model is in a sec. Basically, it's a geocentric, it's a neo-tychonic system for our solar system and presumably the universe, although Mr. Shack does not go into anything beyond the solar system as far as I'm aware of in this text. So I went through those, let's call them 40 mysteries that the TYCHOS model fixes or solves, answers, however you want to put it. And I gave my rough take on all of them. Some of them I couldn't really answer because either I didn't understand what the solution was because I hadn't actually read the full text yet, and a couple of things I didn't have that involved values that I didn't quite know off the top of my head, such as certain orbits, certain orbital periods, and so forth and so on. But the vast majority I think I was able to address. Well, one of the comments that I've got to that video a few days ago, actually, was critiquing the fact that I had not read the book and that they were disappointed that I was attempting to review the book without having read it. Well, that is a great and fair assessment. One should not review something without actually reading it first. I was simply in that video going over what a geocentrist believed to be the problems with the current paradigm, as it were, how our solar system is actually how our solar system is actually structured. Howdy, gay art. So yeah, that's what today is. Today I'm going through, so there are 31 chapters in the book. I've already gone over the 31st. At some point, maybe, I probably won't, but I might put the link to that live stream in the doobly-doo below, but who knows. But I'm going to go over the first 3 chapters today of this book. And so, let us start. It occurred to me that while I was sitting here waiting to get started, that I have not actually... let me do a couple things here. That is not what I wanted to do. Never mind. Just trying to get things organized. Yeah. I was thinking, going through things, that I have not actually read the preface to this thing, or the foreword, or whatever the hell it is. So I kind of went through it, a little bit of it anyway. Come on. Oh Lord, I'm trying to do something and it's making noises at me. All right, we'll just go with it until it breaks. How about that? I can't see the chat, but hopefully I can fix that in a second. So I went through this text, and yada yada, yakety schmackety. Here are the chapters. I'm going to be going over the first three. A brief history of geoheliocentrism. First time I've encountered that term. About binary star systems, our sun Mars binary system, and yes, that is his assertion, is that that our solar system is in fact a binary system, where the sun and Mars are going about a common barycenter, and effectively, well, he actually hasn't explained the rest of it, but I can say that he has stated that Mercury and Venus are no longer planets, but simply moons of the sun, and which is paralleled by Mars, which has two moons, Phobos and Deimos. And so he uses that as something of a justification for why the model works out. And I really do want to see the chat, so let me see if I can get that up. Okay. All right. Howdy, Judy. Hopefully we can work this out. I'm going to show my pretty face in a sec, or again for a moment, and give you my, or OBS is just going to not work. So, all right, well, this is going to be fun. So yeah, it seems that OBS is no longer responding to my commands. So a couple of things that I wanted to show you, I won't be able to show you, but I have at least the text up, and so I can at least show you that, which is all that really is necessary. So yeah, so here are my initial takes on this. This text is somewhat astonishing to me in that it is an amazing example of cherry picking. It is which is, for those of you who aren't well versed in it, is looking through a body of evidence, picking that evidence which supports your worldview or presupposed conclusion, and ignoring everything else. There are just blatant examples of this. There's one particular example which I'll highlight where it is a straight up lie. The way that he presents the information is a deception, and I'll go over that as we go through it. Sadly, OBS is being OBS, and is being non-functional, so I can't share my screens anymore. But in order to essentially prove this, so you'll have to take my word for it. I will verbally tell you what these things is. And yes, I am in fact rather frustrated with this, because I actually took the time and put some things together. That's not usually my MO. Normally I do things on the fly, so I'm a bit miffed. But anyway, he goes in one case his cherry picking is so blatant as to be a deception. But I'm going to go over this. So that's basically my assessment, is that this person has a worldview of how he wants this thing to look, how he wants the universe to look. And he basically looks for any pieces of evidence within the scientific community that supports his idea. Which is interesting because from a science skepticism point of view, at least from a flat Earth point of view, with flat Earth, most flat Earthers, if not, when I say most, I really mean like 99%. 99% of flat Earthers that I've encountered effectively think that any kind of science that deals with space or the planet is bullshit, is theoretical nonsense. This person, Mr. Shack, actually accepts some scientific conclusions, and it's odd to me that, and he on occasion will claim that the current astronomical knowledge actually supports what he states in this text and with his model, which again is new to me. I've never seen this sort of wholehearted or enthusiastic acceptance of conventional science while also ignoring the critical parts of said science. I have the document on my tablet, annotated, so I will show you the unannotated version. Let's start off by looking at the preface. Howdy, Stephanie. You might find this enlightening. Quotes. You guys know how I feel about quotes in a text. So let's start off. This is the preface or foreword or something. Generally parts of the book that I don't read. This is entitled "The Copernican/Keplerian Carousel: Pretty but Impossible." Now, I'm going to take a slight detour to express one of my largest frustrations with this text. And again, one of the most egregious forms of cherry picking that I have seen in this text. So here he actually states Copernican/Keplerian. Everywhere else, and even in the first sentence, he says, "Let us remind ourselves of the Copernican model's simple geometric configuration." He continues to refer to the current understanding of the solar system as Copernican, basically just ignoring Kepler. The problem with this is that the Copernican system and the Keplerian system are drastically different. Yes, they are both heliocentric, but from a fundamental standpoint, they are fundamentally and very pointedly different. So the fact that he is ignoring the Keplerian aspects of the model is telling to me, and particularly in terms of the history of Kepler's role within the Copernican revolution, which I will get into later on. But I just want to state that effectively, while he is addressing Kepler here, Kepler, for the most part, is largely ignored in the first three chapters, except for one part where he basically is attempting to use what Kepler did to support this notion that we live in a binary system. So he states, the Copernican model undeniably appeals to our natural senses. What with its plain, orderly layout, there is a clear middle, and what's more, there is an object occupying the middle, which appears, or which happens, to be the brightest object in our skies. The problem is that its geometric layout gravely, and wow, I cannot speak today, layout gravely conflicts with empirical observation unless you are willing to reject the core principles of Euclidean space. Which is interesting because he mentions Euclid not at all in the first three chapters. again, I have 27 more chapters to go, so maybe he elucidates that on that a little bit more later. But this is the first time that he claims that you have to reject the core principles of Euclid in order to get the Copernican model to work. And it's statements like this where it gravely conflicts. The current model gravely conflicts with empirical observation. He states this more than once. I find this to be very hard to accept, considering that the vast amount of evidence that we have supports the model that we have, hence why it's the model that we have. But anyway, he goes on. The current Keplerian theory, which claims that the sun needs some 240 million years to complete one orbit, clashes with the observable fact that the overwhelming majority of our visible stars appear to have small, quote, local orbits of their own with relatively short periods. He will return to this. Mr. Schack returns to the idea that the sun has an orbit of 240 million years, which is at odds with the binary stars that we see that have orbits far less. What he is doing here, and I honestly don't know why, is he is conflating the orbit of the sun around the galactic center with the orbits of two stars moving around a common barycenter. He admit this is not a mistake. This is not a mistaken understanding of what that 240 million year orbit is. He clearly states that it is the orbit around the galactic center, but he still compares it to binary orbits, which is apples to oranges. The two things are not comparable. Yes, they're orbits, but from a function or on a functional level, I guess they're comparison. But from a physical understanding of what is going on, you have two stars that presumably formed within the same molecular cloud. Trying to compare that to a star that formed a molecular cloud to the entire galaxy as a whole is nonsensical to me. But one of my favorite channels, The Undying Stars with David Warner Matheson, also writes about star myths, is pushing this model but says flat Earth is just flat wrong. Ha! Ha! I see what you did there. Flat wrong. I get it. I'll have to check that out. So, moving on. For instance, Sirius A and B revolve around each other in about 30 solar years. And if you are a fan of my channel, you will know that there is a certain individual out there who claims that Sirius is in fact the only binary star. Well, Mr. Schack would like a word with you on that, and I'll clear that, or that will become apparent very soon. For instance, the Sirius A and B revolve around each other in about 50 solar years. The Alpha Centauri A and B binary pair do so in 79 years, while the Polaris A and B binary pair do the same in just 29.6 years. Other recently discovered binary systems exhibit shorter mutual orbital periods from months to days to weeks to hours. None of our visible stars are observed to have orbits in the range of hundreds of millions of years. Again, this is where that comparison breaks down or falls to pieces. Because if you look at the orbit of Sirius A and B around the galactic center, as he is with the sun, then yes, the orbit is in terms of hundreds of millions of years. He seems to think that the current science is telling us that the sun orbits the galactic center and nothing else does, which to me again is nonsensical. What do the other stars do if they don't orbit around the galactic center? So, yeah, there's a lot of this that just make me wonder what is going on about him. And yeah, so, and then onward. So let's get into it. In the first part of this, and I'm actually going to, for this, do that. First part of this, he defines the terms geocentrism, heliocentrism, and geoheliocentrism. The definitions are adequate enough. I think you all know it. Geocentrism, the Earth is the center of the solar system. Heliocentric, the sun is at the center of the solar system. Geoheliocentric is essentially what is now being called the neo-TYCHONIC system, where the Earth is the center of the solar system and the sun goes around it. Which, again, I have not read the other 27 pages or chapters of this text, but that seems to be in conflict with the general theme that he's presenting in the first 3 chapters, which is that the sun and Mars are a binary pair, where I guess the Earth is located at the very center of that binary configuration, but not really, because, again, just kind of a sneak preview, in chapter 31, he alludes to the fact that the Earth in this system is not actually at the very center. It is slightly offset, which, again, we'll get into that as I get into the actual model itself. But early acceptance of he goes into the history a little bit, early acceptance of the TYCHONIC model. He talks about, in particular, he talks about this dude, that dude, Longo. I'm going to call him Longo. Longo Montanus. Vigo Montoya, or my name is Inigo Montoya. Longo Montanus. I don't know. Apparently he was a disciple of Tycho. To be honest with you, I have done a good bit of reading around the Copernican revolution. Never heard of this dude. But apparently he was kind of Kepler's replacement. Or he may have been a contemporary of Kepler who just went in the other direction. Because Kepler rejected the neo-TYCHONIC model. He couldn't get it to work. Whereas Longo Montanus seems to have continued to stick with it and to revise it somewhat. And Mr. Shack really hangs his hat on this, and he makes the claim that the astronomical community for a good bit of time thought that the neo-TYCHONIC system was in fact the best system. I have never really seen any evidence to suggest this, but he does cite a couple of texts that say this, that seem to indicate that for at least a couple, 5 or 6 decades, that the astronomical community did, in fact, such as it was, did accept the neo-TYCHONIC model. I can tell you that when Kepler sent his work to Galileo completely ignored him. He's like, who the fuck is this? I don't know him. He is not worthy of my attention. Buzz off. He had no comment. There is no written record of Galileo even considering Kepler's work. So I actually don't know what system, aside from not geocentric, that he. I guess he stuck with Copernicus. I don't know. Anyway, going off topic. Now, I have highlighted this, and the beginning of this, I highlighted stuff without actually commenting on it. So hopefully, when reading this, I can, it'll come to me. Again, quoting the case against Copernicus. Oh, this is it. This is the case that I'm talking about. The case against Copernicus is a article in Scientific American, which I really wish I could show you, because essentially it's a short history article right about this time, where the neo-Tychonic model was introduced, and moving forward. Essentially, it was stating that while the Copernican model was revolutionary in that it put the sun at the center of things, there was still pushback. There was still pushback to Copernicus and the notion of the heliocentric model with regards to, sorry, lost my train of thought. Essentially, there was pushback in saying the heliocentric model doesn't work because of the failed. We can't see diurnal parallax, we can't see stellar parallax, so which would be a natural implication of a heliocentric model. So there was some pushback as to accepting that model, and the neo-Tychonic model did offer some advantages or some answers to certain problems that the Ptolemaic model had. Well, here's the quote, as Mr. Schack writes it. Most scientists refused to accept Copernicus' theory for many decades, even after Galileo made his epochal observations with his telescope. Their objections were not only theological. Observational evidence supported a competing cosmology, the geoheliocentrism of Tycho Brahe. I'm guessing that's where Mr. Schack got that term from. The most devastating argument against the Copernican universe was the star size problem. Rather than give up their theory in the face of seemingly incontrovertible physical evidence, Copernicans were forced to appeal to divine omnipotence, as we say back home. The issue is, and he presents this as a blocked quote. It's not. In the article, Case Against Copernicus, Scientific American, you can Google it because for those of you who have come in recently, OBS has shit the bed and I cannot actually switch screens or do anything, so I can't present on OBS what I wanted to present. But if you were to Google the Case Against Copernicus, Scientific American, and read through this, there is a crucial bit that is completely cut about the star size problem. And that is that Tycho and another observer at the time, they viewed stars as having a set size, as having a non-point-like size. So their inference is that the stars must be local because we see them as disks. But as the author of this article states, they were unaware of atmospheric refraction. They were unaware of the fact that the atmosphere itself blurs out the stars, which in the absence of an atmosphere would look point-like. Although not quite point-like because you still have diffraction occurring through your iris, but they would appear far more point-like than they would during the atmosphere. So Tycho's argument that the stars must be local based on the perception that the stars have a physical size is erroneous. The author of this article states that explicitly. Mr. Schack removes it. And he makes this claim, he blocks this out as if this is a solid paragraph as written in the text, and it is not. This is what I'm talking about. This is the blatant, this is not a mistake. He had to knowingly do this. Unless there's a version of this article somewhere that is formatted differently, he had to cut that out. Knowingly. And then presented it. He doesn't put in ellipses. He doesn't indicate that there is some text missing. He simply presents it as if the author didn't say anything. To me, that's active deception. That is a lie. Which I was very disappointed to see. At the bottom, he also says another huge problem was, of course, the outrageous implication that our tranquil planet Earth was supposedly hurtling through space at the breakneck hypersonic speed of 90 times the speed of sound. Yeah. To be somewhat pedantic, the speed of sound where? The speed of sound actually depends on the temperature and composition of the medium. Now, I know he's probably referring to some canonical average value of the speed of sound within our atmosphere, but in space, sound has no speed. The speed of sound is zero because the medium is insufficient to carry sound waves. Why this is such a problem, I don't quite understand. I've seen this frequently with those who claim that the Earth must be stationary, is that it's moving too fast. Well, if it's not running into anything, which effectively the Earth isn't in its orbit around the Sun, nothing substantial anyway, there's nothing to smack into. There's nothing to distort things. And as has been frequently stated on other better debunking channels, we don't feel velocity. The classic example is sitting in a plane. If you're in a plane and it's at night or what have you, and the other people or the windows are drawn, you have no sense that you are traveling at 300 miles per hour, pardon the imperial units, or thereabouts. You are traveling at a breakneck speed. You are traveling not quite supersonic, but you don't feel that. You feel acceleration. Yes, Stephanie, at the equator, Earth rotation is faster than Mach 1. Okay, it's not slamming into anything, so why would that matter? And as I just stated, we don't feel velocity. We feel acceleration. And as I Can Science that showed, we don't feel a whole lot of acceleration at the due to the Earth's rotation, centrifugal or otherwise. So I will express a certain amount of frustration with that argument. He goes on, talking a little bit about the history. Here are, he talks about an Indian, the Indian Tycho, which I have to give thanks to Mr. Shack. I did not know this individual existed. I looked into him, and yeah, apparently he did similar observations and came up with a similar model to Tycho Brahe a few centuries after the fact, or maybe a couple centuries after the fact, using instruments made up of wood and bamboo, which boggles my mind. Unfortunately, Mr. Samanta, Mr. Samanta doesn't have a written record of his observation. Apparently, his models and his assertion or his conclusions were written by other people, basically kind of like Socrates. Stephanie, you realize that turbulence is acceleration. You feel it because you are being accelerated up and down. There is no rotation. All right. So I need to look into this individual more often, because one of the things I have felt that is a severe deficit in my history of astronomy knowledge is basically anything that is further east than Iran, basically. So he's presenting that the fact that the neo-Tychonic model was not simply Tycho, that someone else independently came up with it. He argues that it was independent, and the arguments that he gives are pretty sound. I agree with him that the chances that Samanta, the chances that Samanta actually knew of Tycho's work are pretty low, I would think. So, where are we? It's up here. I highlighted, as you can see, the models of these two outstanding celestial observers are virtually identical. I've highlighted in yellow and red the intersecting orbits of Saturn, Sun, and Mars, which are clearly consistent with what we would today call a binary pair. Sorry, Stephanie, I don't mean to ignore you, but I highlighted this because this is the first flag that went up to me. I read that and was said, binary pair? Your indication that the sun and Mars have intersecting orbits? Well, so does the sun and Venus and I think oh yeah, the sun and Venus and the sun and Mercury. Like, why Mars? He does actually address that question. Not to my satisfaction, actually. Quite the opposite. So here's the first indication that he believes that the sun and Mars, based on these models, the configuration of these models, that Sun and Mars are in fact a binary pair because they have intersecting orbits. And if you look at a binary star system from an outside frame, yes, the two stars will orbit around a. Is it the outside frame? No, it's the frame of the barycenter. If you are looking at the orbits in the frame of the barycenter, then yes, the two stars will appear to be orbiting around, and their orbits will intersect. So again, it's things like this. Like, he obviously is not ignorant of conventional science. He just simply gets it wrong, or chooses to ignore some very obvious parts of what he's looking into. I've highlighted this quote: "How and why did such diverse astronomers have after lifetimes of tireless observations eventually reach such strikingly similar conclusions, particularly with regards to the intersecting orbits of Sun and Mars?" Well, I hate to break this to you, but this is not a unique situation. There are examples in astronomy where two disparate individuals or two disparate cultures developed ideas along the same lines. I can't remember exactly who it was, but I will get this wrong. But it was a Mesoamerican civilization and a civilization in like Babylonia, Babylon, in that area. Those two civilizations came up with exactly the same, or very nearly exactly the same, reckoning of timekeeping. They're separated by the Atlantic Ocean. Really hard to argue that a Babylonian went over to, I guess it was the Incans, and said, "Hey, check out my system of timekeeping," and run with it. No, or it was the Mayans. Like I said, I don't remember. I do remember, though, specifically, there was someone in Central and South America. Pardon me for potentially misusing the term Mesoamerican. Either the Incans or the Mayans came up with a system that was nearly identical to ones that were developed by the Babylonians and the Chaldeans. So yeah. This is not unique. This is not so asking that question is people come up with similar lines of thought while being completely ignorant of each other. Comedy has this problem. People come up with the same jokes, or video commentary. When people look at soft SIDS or whatever, they can come up with the same kind of explanations for things independent of one another. It just happens. He then claims that Samantha and Tycho Brahe are virtually unknown to the general public today. Samantha certainly is, and I would bet that Samantha is actually virtually unknown to Western astronomers, even the ones today. Tycho Brahe, not so much. Would you expect the general public to know who Tycho Brahe was? Would you expect the general public to know who Copernicus was? Or Kepler? Or Ptolemy? I wouldn't think so. If they know Galileo, then Great, but I'm pretty sure they know about Galileo because he pissed off the Catholic Church. If he hadn't pissed off the Catholic Church, I doubt they would have heard of him. Maybe they would have heard that he had invented the telescope, which he didn't. But, you know, I don't understand that sense. As I see it, the idea of the Earth and Earth alone would remain completely immobile in space is a most unfortunate failure of imagination. No one is... the only person actually who stated that was Ptolemy. But, you know, hey, what are you going to do? Yada yada, telescopic era, namely that the Sun and Mars are in fact interlocked in typical intersecting binary orbits, much like the vast majority or quite possibly all of the surrounding star systems. I'm going to return to that because this seems to be a linchpin in this model, or at least his argument for this model, is the statement that that the vast majority or quite possibly all surrounding star systems are in binary systems. That's not accurate. Not by half. He then goes into another thing I highlighted was down here he says that every 2 years or so, more precisely 2.13 years, Mars and the Sun transit at diametrically opposite sides of the Earth. This is what we call the Mars opposition. This same thing happens with Jupiter, not on these timescales, but oppositions occur with Jupiter, with Saturn, with Uranus, Neptune, anything that has an orbit larger than the Earth. Again, why he is focusing on Mars? It seems to me a numerological. He is fond of numerology. It seems to be that the numbers seem to speak to him. He likes their symmetry, and that is why he is going with it. Coinciding the Mars' closest approaches to Earth. Yet to this day, in spite of this peculiar behavior of Mars, reminiscent of the regular close encounters observed in binary star systems, it seems never to have occurred to modern astronomers that we live in a binary system. That second one is false. There are actually people who believe that the Earth or the Sun actually was in a binary or at least multiple system sometime early in its history. But the consensus is that I think the almost complete consensus among astronomers, I have never heard anyone or read anywhere that the Sun is currently within a binary system, as astronomers define a binary system. And again, he points out Mars as the oppositions of Mars being the thing that would indicate we are in a binary system. Well, what about Jupiter? And Saturn? And really, what about Jupiter? Because there's the mass issue. He addresses that later. A fundamental point of the TYCHOS model will demonstrate that it is our solar system our solar system is most remarkably interconnected clockwork or gearbox, the mechanism of which features our moon as its central drive shaft and extends all the way to the outer planets. Yet, modern astronomers have been suggesting that our outer planets are governed by chaos. Couple things. He does not address the moon again in the first 3 chapters. So if you were wondering how the moon is in fact our celestial, how did he put it? Central drive shaft, you'll have to wait to the next video, at the very least. Modern astronomers suggesting the outer planets are governed by chaos. Chaos is a loaded word. Or not loaded. Chaos has a very specific mathematical meaning. I don't really know it because I'm not a mathematician. Clive could probably tell you. And so I don't know if that actually applies to the solar system. I don't know if the solar system is, in fact, mathematically chaotic. What I can tell you is this. N-body simulations, and what an N-body simulation is attempting to predict the future locations of multiple bodies, greater than three or greater, really, using gravitational interactions. You may have famously heard of the three-body problem. I've talked about it before. And I know I'm probably going to get corrected again. To my understanding, there is no analytical solution to the three-body problem unless you make certain crucial assumptions. Namely, that the third body in question has a negligible mass in relation to the other two. That's the one that I'm most familiar with. In the solar system, you can't make that. Well, I suppose you can make we do make those certain assumptions, but what I'm getting to is that we can do M-body simulations which will predict what the orbits of the planets going around the sun will look like over the next 10 years, 50 years, 100 years, thousands of years. But when you start getting into tens of thousands of years, our models break down because those assumptions that we were making in order to predict those motions, the error associated with making those assumptions, because those assumptions are not strictly physical, the errors associated with it grow as time progresses. And so our predictive ability degrades over time. Scam, it's over. Stop calling me. Anyway. So I think that's what he means, that the modern astronomers suggested the outer planets are governed by chaos. The outer planets are governed by a lot of nearly comparable gravitational interactions with surrounding bodies. The ice giants, other comets, other dwarf planets, things of that nature. And so that does add some problems when it comes to actually predicting the motion of things on large timescales. Now, this is also reminiscent of Newtonian era thought, where the universe was entirely deterministic. This is where the theory of everything comes in, where this idea that we understand physical laws so well enough that we can combine them to get a theory of everything that will in turn be able to predict the physical motions and reactions of all things over all times. Hawking, before his death, rejected this idea. Most notably, you have the Heisenberg uncertainty principle, which kind of negates the possibility of a theory of everything. So it seems that Mr. Shack is, in fact, a determinist. Which, all right. He does actually supply his references, which is nice. Is our sun a single star? So he starts off with this silly, it would be the most polite word I can use for it, conversation with a child. Talking, and the child asks, is the sun in a binary? Or does the sun have a companion? And you have to tell them, no, astronomers, quote, that's what the astronomers say, honey, and they should know. They tell us the sun is a single star. What I quoted is the child's response. It's not fair. If all the stars in the sky have a partner, then our sun should have one too. You could then attempt to save face by reminding the child that you didn't say all the stars, but practically all the stars. Again, going on to the fact that the sun is in his mind, the sun is a binary. He then defines the basic three general types of binaries. You have visible binaries, two or more gravitationally bound that are separated visibly in a telescope. Non-visible binaries, those binaries that are that are gravitationally bound but appear as one because we do not have the angular resolution to separate them and see them as two separate bodies. They're either far too far or far too close together for that to happen. And then you have optical doubles or double stars. These are basically chance alignments. These are stars that appear like they are next to each other in the sky, but are in fact hundreds of, or possibly even thousands of light years away from each other in reality, from depth. Stephanie, you've never heard of Tycho, but are very familiar with Kepler and Copernicus. Interesting. Okay. This comes into play. It took me a bit, but the optical doubles is, I think, where he gets tripped up. And I have to blame the Australians for this, to be honest with you. But I'll be kind. I will blame. They are radio astronomers, and as we all know, radio astronomers are dirty, dirty cheaters. Anyone who can observe stars in the day, in the rain, cheat. That's all I gotta say. Quote, what we shall see is that when considering the most recent discoveries of observational astronomy, a reasonable case could certainly be made that 100% of the stars in our skies are in fact binary or multiple star systems. This is wrong. Flat out wrong. I will, again, I really wish I could show you, but I can, if you email me whatever, I can promise you I will send you the papers. The two stars in the system revolve around each other in intersecting orbits, also known as a common barycenter or center of mass, lacking for a better term, completing a revolution in variable time periods ranging from hours, weeks, months, or more rarely a few dozen years. I hate to break it to you, but Albireo has been the most. Our evidence that to date suggests that Albireo actually is a binary pair with a period of 10,000 years. So the periods can actually get much greater. He gives some examples. For example, I don't know why I highlighted this, but I highlighted the binary system Alpha Centauri circle each other circa 79.7 years. I think I highlighted that because I may be wrong, but I think he makes the assertion that Sirius and the Sun may actually be a binary companion or binary star system, which I found to be weird because Sirius is the fifth closest star to us, with the Alpha Centauri system being the closest. Here we go. Unfortunately, a number of modern astronomy textbooks still state that no more than 50% of stars are binary systems, neglecting to report the mounting evidence that over 90% of the known stars have companions. He then states, in fact, the majority of stars happen to be in multiple in binary multiple systems. Consequently, binary star research covers most areas of astronomy. If I remember correctly, that comes from a online Pop Science article, and which I checked out and I clicked on. I actually figured this out after. What I did was, are you responding? Can you behave? No, you're not. So let me bring it up. I typed in this phrase to Google, and you can do so yourself and follow along. What percentage of star systems are binary? The AI states that, Google's AI anyway, estimates that up to 85% of stars exist in binary systems. Space.com, it is estimated 85% of stars exist in binary systems. Blah, blah, blah. One of the articles in question points to this website because if you keep going down, you get to the Australian Telescope National Facility Introduction to Binary Stars, which Simon Shack references. And of course, this is go. Is it going? Sorry, my internet is. Which he references later on. He actually takes images of what a binary star system is from this website. You can go to this website. You can go to the Australia Telescope National Facility website. Go to the binary stars page. It will state that perhaps up to 85% of stars are in binary systems, with some in triple or even higher multiple systems. There is no reference to this. There is no reference to a paper. It simply states it. These are radio astronomers. You don't do binary work in radio. You just don't. It does not have the angular resolution necessary to actually do this. Why the Australians feel that they need to talk about this on this website, I don't know. But I can say that the links, there are a lot of broken links when it comes to, what is it? Did I look at binary simulation? No, that actually works. When it comes to resources to learn more about binary stars, there's a lot of broken links. So I don't know what's going on there. I don't know if that's indicative of anything. But what I can say is this. According to Raghavan 2014, written in published in AppJ 2010, so it is dated. I know this specifically because I know Deepak. I know the first author. I was in the room when he was doing this research. Second. In it, again, in it, he states that 51% of all sun-like stars are single. He doesn't. So he is stating that the vast majority of not vast majority. Sorry, getting ahead of myself. Deepak found through intensive study of using multiple different types of observational techniques, from speckle interferometry to infrared interferometry, optical infrared interferometry, from spectroscopic analysis, from multiple sources of multiple techniques, or adaptive optics. What he found were that approximately 51% of solar-type stars are single stars. And I really wish I had the fractions. Maybe I'll make a short and give you the actual numbers. And then he goes on to binaries, triples, and then multiples. Winters et al., I think it's Winters et al., in 2018, again, I will have to look that reference up, did a volume-limited study of M-dwarfs. This is particularly important because, as it turns out, when we will think about the multiplicity of stars in the research, we don't talk about all stars for reasons, probably because it's easiest. We split stars into categories, and probably that we are probably most interested in. And we look at multiplicity studies of those stars. So, like I said, the statistics that I was just referring to are not all stars, just simply stars that are like the sun in temperature, and radius, and age-ish, but not 85%. So you might think, oh, well, what about other types of stars? What about the hotter stars? What about the cooler stars? Maybe there is a significantly large fraction of those that makes up for the lack of binary companions in the sun, sun-like stars. And to note, that is an applicable stat to say because he is stating that the sun is in fact a binary. Well, we know that based on our current, our current understanding, our current data strongly suggests that sun-like stars are mostly, barely, 51% or so, single, not binaries. But, to be complete, what about other stars? What about other stars? Is the multiplicity factor for those very high? Are those close to 100? Well, Deepak, his advisor is Todd Henry. Todd Henry runs a research group at Georgia State called Recons. Recon's job, sole goal, is to map out every single star around the sun in what we call a volume-limited sample. This is different from what we call a brightness-limited sample. A brightness-limited sample says that I am going to look at everything within a certain brightness range, or down to a certain brightness limit. The problem with this is that the apparent brightness of an object is dependent on two things: its intrinsic luminosity, how bright it actually is, and its distance. And so by looking at the apparent brightness of something, you are already introducing what we call a selection effect, or a selection bias. You are only looking at those stars that are superfluous, that are either very close to you or intrinsically very bright. So it does not really take into account the physical nature of the object. They're useful. Brightness samples are useful from a statistical standpoint, but everyone who looks at them knows implicitly there is a bias. So it's not presenting the complete story. A volume-limited sample, on the other hand, is one where you say, I want to find everything out to 50 parsecs, which is about 75 light years or so. 50 parsecs is around 150 light years or so. Ish. We astronomers like to use parsec rather than light years I don't know why light years popular. Anyway, so out to 50 parsecs. So we do an exhaustive search of all of the low luminosity objects, and Recon's just published or is just about to publish, because I've seen some posters put up around 20 this year and last year that are going to put out the results of their 50 parsec sample, where they believe that they have found all of the stars, or the vast majority of the stars, within 50 parsecs. This allows for a true analysis of what the stars around the sun actually looks like. Now, if you make the assumption that our locality is not preferential in any way, you can then expand out and basically say, okay, what's happening around the sun is representative of what's happening around other stars. You can take or leave that assumption, but what I can tell you are some of the earlier results from this. Interestingly enough, the studies so far of the stars within the solar neighborhood of M dwarfs, these are cool stars. These are stars that have a temperature roughly about half that of the sun, surface temperature roughly half that of the sun. They have a mass of about half that of the sun or lower. Their multiplicity fraction, and this just says binary or otherwise, is actually in the high 30s. M dwarfs account for the vast majority of stars in the universe, or at least in the galaxy. When you create a system of stars Our current understanding is that for every really high mass star, O star as we call them, for every single one of those that you create, you get 200 M dwarfs. So that statistic is completely contrary to Mr. Shack's claim and the Australians' claim for some reason, is that the vast majority of stars, as a function of temperature, are in fact single. So I don't know where this is coming from. I don't know where. He is obviously getting it from the Australians. At least one of the articles I picked up, they cite on what they cite. You click on the link, you go to the Australians. I don't know what's going on. But from the research papers that I have found so far, indicate that the binary fraction is far less than 85%. Yes, and he will go on to start making claims about all these other binaries that have been found. And that's true. As our observational ability gets better, as our ability to see fainter objects improves, we're going to find more and more binaries. But that's not changing the fraction up to 85. Individual little discoveries here and there aren't getting us to 85. They sure as shit ain't getting us to 100. So the whole linchpin of this, that the sun must be in a binary star, that the astronomical community's own observations indicate that the sun must be in a binary system, is wrong. It doesn't hold water. Now, I thought initially, or after this, that he was, because I already know that he conflates apples and oranges, that maybe he's talking about exoplanetary systems, because in that case, the statement is accurate as far as we know, is that from the observations that we have currently gained, we believe that every star, as I say, in the night sky that you can see has or has had a planetary system going around it that's in some way or another. But no, he addresses that as well. Dr. Nimrod, I am not going to talk about my anus on this stream. This is a family stream. Thank you very much, sir. Yes, Stephanie, I knew that you were going to latch on to assumption, and that is why I made the statement. You can take it or leave it. I think the assumption is valid because I do not know of any physical justification for why it would be invalid. Simply because it is assumption does not does not mean that it is wrong. Or cannot be applied. All right. Let's see the next thing I highlighted. Oh, he makes this statement. Apparently somebody somewhere made the statement, sooner or later the Sun and Mars must smash into each other in a neo-Tychonic system. I've never heard this. I don't know what he's talking about. For some reason I highlighted it. He then quotes this thing. The binary star database made by some Ruskies. Damn Soviets. This is a Russian group, and in it, they do not state 85% of stars in the Milky Way galaxy are not single. They simply give you a date. No, maybe they do. I can't really remember. This is not a paper, not really. This is a preprint, which means that it was not peer-reviewed, but it's really just an advertisement. What they did was cross-reference catalogs. They did what seems to be an exhaustive search of all of the known catalog and picked out all of the binaries that they could find. And they put them all into a single database. Now, here is the issue. I looked into it. And again, can't show you. I know that seems like a cop-out, but OBS. You can Google, and again, I can provide the context. Howdy, Al. I can provide any links required. I looked into the binary star database. I looked into that advertisement. And I looked into which catalogs they were using. And something struck me. One of the catalogs well, first off, they admit that the vast majority, a large fraction, not vast majority, I shouldn't say that, a large fraction of the binaries they list in their binary star companion are visible binaries, meaning that these are stars in the sky that appear close to each other. Now, Mr. Shack refers to visual binaries correctly in that they are gravitationally bound. And he makes the distinction that optical doubles are not, or double stars are not. Well, I looked at it, and lo and behold, what should I find but the double star catalog by the Navy, run by Brian Mason, also a friend of mine. The double star catalog has tens of thousands of entries. They are not confirmed to be binaries. They are all optical binaries. And actually, one of the things that Brian really wants done, and he's trying to last I talked to him, which is a while ago, he was having trouble getting people to actually get on board, and he wanted to basically crowdsource this to citizen astronomers. He wanted to get these things verified. These are hypothetical. These are possible binaries. And so what I think is occurring here is that somewhere along the lines, maybe it was these Ruskies, I don't know. Sorry, I shouldn't be offensive. Maybe it was these folks. But they included the entirety of the double star catalog, which are not confirmed binaries. Yes, some of them are. I don't know what fraction there are, but they are not confirmed binaries. And they're sticking them in there as if they are, in fact, binaries. And so I don't doubt, and it may in fact state it in there explicitly, but I don't think so. I don't think they actually talk about multiplicity fractions, what the fractions are of things. But given the numbers, then yes, you could probably get to 85%. But that's biased. Those are not confirmed. Those are optical double. A large fraction of them are optical doubles. So, again, cherry picking. He did not do his own research, or he did not sufficiently do his own research. Let's see. Clearly, binary systems are anything but rare, as believed only a century ago. For instance, we know today that the 20 stars closest to Earth are, in all probability, locked in binary systems. I've meant to actually look that up, but sadly I didn't have the time. But what I can tell you is the study that I just quoted, the volume-limited study of M dwarfs, the vast which within 50 parsecs corresponds to about 70% of all stars. Only 30% of them are in multiple systems, not just binary, but higher order. So I don't know what to tell you. His contention is that the binary stars that we are not seeing are because of the difficulty there is to see them. And yes, that is a valid point to make. There is a bias in that sense, is if the mass fraction, if one star is significantly more massive than the other one, meaning that it is probably more luminous than the other one, then it is possible that the smaller companion can be hidden from view. Is there enough of those types of systems to make up to basically state that all stars are binaries? I think not, because what the evidence is also suggesting to us is that binaries, the mass fraction, if you take the ratio of the mass of one star with relation to the other, the mass fraction is nearly close to 1, meaning that they are binaries tend to be equal mass or very close to equal mass. Non-equal mass, like if you have a ratio of 0.1 where one star is 10 times this mass of the other one, those are exceedingly rare, or at least far more rare than equal mass approximately equal mass binaries. So we refer to that as by the value Q. There are many more binaries with a Q value of 1 than there are values of 0.1. So again, it goes against what he is stating there. And again, he just this is this alcohol? Oh no, this is the binary system with the very romantic name of HIC 59206. This is a great illustration of how adaptive optics helps astronomy with angular resolution problems. Is that given the atmospheric distortion of stars, if you don't have adaptive optics with a large telescope, this is the European Southern Observatory, so the size of this telescope is more than likely 8 meters, you can't see it as 2 stars. There is some sort of, because it's oblong, there is some kind of hint that maybe it's 2 stars, which is probably what motivated them to look at it using adaptive optics. And lo and behold, 2 stars. Adaptive optics, as I've described before, is just simply a technique to mitigate the effects of atmospheric distortion. He states, to wit, if it eventually emerges that 100% of stars in our skies are binary multiple systems, the current Copernican heliocentric theory, which holds that our sun is a companionless star, will have to be definitively abandoned, beyond appeal, for being a most improbable exception to the rule, or, if you will, a one-of-a-kind cosmic anomaly. Unless one accepts the truly astronomical odds of our own star, the sun, being the one and only quote-unquote bachelor in the entire universe, a most irrational and exceptionalist notion, if there ever was one. In any case, the situation we have today is that virtually all of our nearest most stars are observed to have a binary companion, and more are continually being discovered with no end in sight. Wrong. That's just simply the astronomical evidence. The research papers I found do not state this. That is just not true. And his entire argument for this, a main linchpin of his argument for this model is this, concisely put together. And he's saying 85, and now he is moving the post to 100%, and stating that if it is found that all stars are binaries, then in fact the sun can't possibly be a single star because, reasons. Then, all right, so now, I mentioned before the whole thing with there it is, right here. I mentioned before the whole exoplanet thing, where we believe that the current data is telling us that all stars have or had planetary systems around them. He says, rarely, though, if at all, it is suggested that some of these exoplanets might be formally unregistered companions of larger stars, possibly because of the growing, quote, academic fear that all stars, without exception, may turn out to be binary multiple systems. The scientific establishment is obviously keen to avoid such a conclusion. There could be no more horrifying prospect for, quote, mainstream astronomers, for lack of a better term, than having to admit that stars are by definition binary/multiple system, as this would spell the end of geocentrism. He points to a very pertinent question within exoplanet science. A lot of, or at least one of the main workhorse techniques to discover exoplanets has a bias sort of baked into it, and I hate to say that astronomers are being human with this. So one of the techniques called radial velocity, the signature that we get is not only dependent on the mass of the star, but also on the inclination of the system. So when you read about these things, unless there is some way to constrain that inclination, astronomers really like to present the best case of a planet. They will state, this is a planet of this many times the mass of Jupiter, basically assuming an inclination of 90. But if you tilt it upwards, the mass grows. In order to get the same observational signature, the mass of the companion has to grow, such that if you have a very low or high, it's backwards. Flat is 90, face-on is 0. If you have a very face-on orbit, then the mass of the companion becomes stellar. So it's not an exoplanet, it's actually a binary star system. This is something that we are aware of. This is something that people are looking into. There is actually one guy out there who has now kind of named the planet killer, because he looks at these systems and actively tries to figure out whether or not these systems are actually truly exoplanets, or if they are substellar, or if they're low mass substellar companions, brown dwarfs, that sort of thing. And he has made a name for himself for being fairly good at it, of coming up with techniques that invalidate the conclusion that these are in fact exoplanets. Ta-da! Science correcting itself. We as scientists recognize that we cannot be simply settled on one paper. We cannot simply take one person's word for it. We need to revisit these systems and try our hardest to negate the conclusions that were made. So there are other astronomers out there. He is the most notable, whose name, of course, I have forgotten. And so this is not something that we are afraid of. This is not something that we are... Again, it speaks of the academic establishment as being monolithic. It's not really. There are some vestiges to it of being monolithic, but there is no... We don't have a leader that from on high tells us proclamations. So, yeah, we don't have a fear of anything of that. Then he goes on and talks about how the TYCHOS model violates Newtonian laws. Not entirely certain how. Moreover, and then his way of addressing this is, moreover, Newton's laws have been seriously challenged by numerous physicists over the past 3 centuries, and many paradigm-shifting astronomical discoveries have been made, even in the 21st century. So rather than continue to appealing to, quote, Newtonian authority, I suggest readers leave Newton's sacrosanct laws at the door for now and allow themselves to take an unprejudiced look at the undeniable evidence of our telescopes and the plain facts of geometry. This is simply a misunderstanding, and he states that here. This is the point where he states this. I don't know where he is getting has been seriously challenged by numerous physicists over the last 3 centuries. There have, in terms of paradigm-shifting astronomical discoveries, really the only thing I'm thinking of is around the turn of the 20th century with relativity. I have talked at length, many creators have talked at length about how Newton's laws cannot be thrown to the side. They are still valid, but we recognize they are only valid within a certain set of parameters. Things that are moving very slowly, things that are not moving in in very large gravitational fields. The solar system, for the large part, except for the notable exception of Mercury, can be treated classically. It can be successfully looked at and predicted using Newton's laws. So the idea that we have to throw it out is misunderstanding the current science. He then quotes somebody who, again, I didn't look into. It says that Oh, he also says that Isaac Newton didn't know about binary, so then if he did, he wouldn't have come up with his theory, his law of gravitation. Or his laws of gravity. I don't know where he... Sure. Okay. He quotes this, whose name is further down in the reference list. If the general relativity method is correct, it ought to apply everywhere, not just in the solar system. It does. Who doesn't? I don't know who says it doesn't. But Van Flanderen, whoever that is, points to a conflict outside it. Binary stars with highly unequal masses, their orbits behave in ways that the Einstein formula did not predict. Physicists know about it and shrug their shoulders, Van Flanderen says. They say there must be something peculiar about these stars, such as an oblateness or tidal effects. Another possibility is that Einstein saw to it that he got the results needed to explain Mercury's orbit, but that it doesn't apply elsewhere. Effectively, that is basically saying he backwards engineered the explanation for Mercury's anomalous orbit perihelion shift. I have heard this from the Aether community as well. I don't see any evidence of it. I don't know how you would backwards engineer it, but I'm not entirely certain. In terms of these, of what this person, Van Flanderen, is stating with highly unequal masses behaving in ways that the Einstein formula does not predict, I haven't really looked into it. I suspect, I will admit, haven't looked into this aspect of it, but I believe he's referring to black hole binaries, which are just weird. We do not understand black holes very well. And so, do they violate relativistic laws? I don't know if you can make that claim, because then you would have to know a lot more about black holes than we do. Again, to me, this is grasping at straws. About variable stars and flare stars. Yay! We have, which is in my wheelhouse, intrinsic variables, extrinsic variables, a flare star. So, just so you know, an intrinsic variable is a star whose apparent brightness varies with time due to some intrinsic or internal physical mechanism. It pulsates, for example, or it blows up, for example. Extrinsic variables are when the apparent brightness changes because of an outside factor. The most common of which is an eclipsing binary, where the one star passes in front of the other star and blocks out the light. Oh, Van Vlanderen described dark matter, missing planets, supported the Lesage's theory of gravitation. All right. Probably why I don't know. I need to look into that, I guess. But that's intrinsic and as extrinsic variables. I love this little line. I didn't highlight it. I think we can all agree the hypothesis of stars that periodically swell and shrink is rather outlandish, but let us move on. Okay, I don't, but because we have pretty solid evidence that they do, both photometric and now interferometric, we actually have measured directly measured the size of a star in various times of its oscillation and found that its radius does in fact get bigger and smaller. So, outlandish? I don't think no sir, we cannot all agree on that. He talks about a flare star, an RS Canvan. Personal favorite of mine, RS Canvan is a highly magnetic star. And as highly magnetic stars are known to do, and even non-highly magnetic stars like our sun, the magnetic field will become extremely complicated, twisted, and the magnetic field lines will, for a lack of a better term, snap. And when they do so, they release a tremendous amount of energy, which blows off, or release a tremendous amount of energy, particularly in X-rays, which we note to be flares. Now, RS Canvans are thought to be binary stars. They usually have the RS Canvans are actually typically unequal mass binaries where, nope, sorry, taking that back. They're unequal size. RS Canvans are binary systems in which the primary companion has evolved into a giant star, and it has either a subgiant or a main sequence companion. The companion is essentially that binary nature has essentially spun up the orbit and thus spun up the star. You make the star go faster, you make the magnetic field stronger, you make it go twisty and snappy better. For lack of a better way of putting that. I loves me some RS Canvans. He states, in both cases, variable and flare stars, we see that the least speculative explanation for these stars are quite simply binary star systems whose brightness periodically dips as one companion obscures the other. I suppose there's a case to be made there, but that does not say anything to the overall multiplicity of binaries in general. Yes, variable stars, a good number of variable stars are in fact in binary systems. Cepheids are not, Miras are not, or our Lyras are not. All of these are pulsating variables. So I don't know exactly what his argument is somewhat flawed with that. He moves on and states, in the TYCHOS model, of course, this would be the case. The Sun would, in fact, be a binary companion because of Mars, which exhibits the characteristic orange hue associated with red dwarfs. The rather bright shine of Mars is due to solar light reflection. He states that. Yes, he thinks that he knows that Mars is a rock and that we can see it because of reflected light. Now, Mars is only about 0.5% the size of the Sun, and Sirius B, the tiny companion of the brightest stars in our sky, Sirius A, also happens to be about 0.5% of the size of its largest partner. I have not verified that the mass of Mars is in fact 0.5% of the mass of the Sun. Maybe it is. I don't know. I haven't checked that. I don't know about that specific number. But I can tell you about Sirius A and B. Sirius B is a white dwarf. A white dwarf is a star that is roughly the size of the Earth, that has the mass of half of the Sun, generally speaking, or on average. So you're talking about something that is the size of the Earth, or comparably Mars, that has the mass of 1/2 of the Sun, which Mars does not have. Here, he is comparing the two systems in radius, not in mass. He uses the term size. He does this a couple of times. I hate using the word size when it comes to comparing objects in astronomy, in astronomy, because it's ambiguous. When you say size, what are you referring to? Are you referring to the mass, or are you referring to the radius? These are very different quantities. And they have very large impacts or non-impacts to various different astrophysical quantities. For example, the radius of something really doesn't tell you anything about how that star is going to evolve over time. That is a function of mass. So again, here's comparing apples to oranges and attempting to use that as a justification for using the model. Which again, he knows about Sirius B. How many people know about that Sirius is a binary star, except for the one young lady whose name I can't remember, Martha Marion or Meredith or whatever her name is. I think it's Meredith. Like, how many people know that Sirius, the dog star, is in fact binary? You got to look that up. He then goes into the most recent discoveries of stellar companions. Most of this is simply talking about, as I've said, as technology has evolved, as technology has gotten better, we have been better at finding smaller, fainter companions. We have been better about finding black hole companions, or companions that are black holes, and so forth. So yes, we're finding binaries all over the place. Does that amount to 85, 100% multiplicity fraction? No, it doesn't. You're taking specific little discoveries and conflating it to a larger number, to a larger implication. If you want to look at these things, you need to look at those studies that are specifically geared towards answering that question. And there are a few of them, which I can point you to. Then, for some reason, he switches gears and talks about Barnard's star, the star with the greatest proper motion. Proper motion is the motion of a star relative to other stars within the plane of the sky. So not backwards and forwards, but left, right, up, down, and everywhere in between. Barnard's star is the one moving fastest to us in relation to all the other ones. And so it is notable, and people have obviously studied it pretty extensively. Well, two gentlemen by the name of Heinz and Van de Kamp, particularly Van de Kamp, looked at Barnard's star, and I think in the 70s? I can't remember. In the 70s, or whenever, Van de Kamp made the claim that Barnard's star had a companion. Not just a companion, but an exoplanet. He saw a wiggle in the proper motion. So Newton's first law tells us that an object in motion will stay in motion unless acted upon by an outside force. So if it's a single star not being acted upon gravitationally by anything else, at least appreciably, it's going to go that way. Like that. Just like that. But if it has a star or a planet orbiting around it, it's going to do this. And more specifically, it's going to do this. It's going to move it's going to wobble in two directions. Right ascension and declination. And he published this, and he published a very clear signal indicating that that Barnard's star, its proper motion, wiggles. If, again, email me or whatever, and I can send you the paper and you can see the amplitude of it. No one else could replicate it. One of the most important or fundamental aspects of astronomy or science is to be able to replicate the results of someone else's experiment. No one else could. And when Van de Kamp spoke, Van de Kamp was a very well-renowned and respected astronomer. When he said that he found an exoplanet, people were like, wow, all right, this must be taken seriously. And so a whole lot of folks looked at Barnard's star, and none of them could verify this. None of them saw the same signal he did, or really any signal at all. We still don't know exactly why his observations showed the signal that it did. Could have been systematics in his telescope. I think Mr. Shack points out something. Another explanation. It really doesn't matter in the grand scheme of things. It wasn't, basically his claim that it was an exoplanet didn't bear fruit. The community did not accept this claim. He died saying that he was the first person to find an exoplanet. Well, then then Mr. Shack goes on and talks about the fact that in it was the 60s. All right. Mr. Shack goes on and says in 2018, the Europeans found Barnard's star B. Barnard's star does in fact have an exoplanet. And so somehow Mr. Shack thinks that this is, yet again, supporting the argument that all stars are binaries. Here again, he is using exoplanets. He is conflating a planet with a star for reasons I don't understand, which is not how a binary star works. That is not the definition of what a binary star is. I can also say that this does not, what's the word I'm looking for? This does not validate. Stephanie, we've talked about the distances of these stars. Again, until you can tell me why the radar finding method doesn't work, then I don't think we can have a conversation moving forward. Howdy, Doc. Because yeah, the distances clearly show that we live in a large galaxy, or a large galaxy in a vast universe. Anyway, vindicate, that's the word. These observations do not vindicate Van de Kamp, because this planet would not have produced the signals that Van de Kamp saw. And given that the data is telling us that all stars do in fact have planets going around them, the fact that he said that there was a planet going around Van de Kamp, or Barnard star, well, obviously all stars have planets going around them. He just didn't see it. So why this is included in this book as justification, I'm not sure. He then makes a perplexing statement. Whatever the so apparently also in this saga, they tried to look for a binary, or they tried to look for an exoplanet in the 80s and 90s and stopped because of funding. But then in 2018, they found it. They went back, got money, and actually discovered it. So this little segment doesn't make any sense to me. Quote unquote, lack of funding is not entirely a convincing explanation. I can tell you, as a professional astronomer, it certainly is. This idea that we make bank is way wrong. Way wrong. So lack of funding is common for when it comes to non-sexy ideas. There's only so much money that we can squeeze out of our federal government. But anyway, lack of funding is not entirely a convincing argument. Whatever their motivation is, one fact remains of which there can be little doubt. Van de Kamp's solitary endeavors succeeded where NASA's efforts had failed, in spite of so much of their touted multi-million-dollar space telescopes and immensely superior resources. But you just told us that they found one. So what? I is confused. You're ragging on NASA for something they helped do. They found it. So what? Confuse. Anyway. He then goes on to additional links of planets are exactly like stars, only not gaseous or incandescent or similar in composition. Close enough. So, more quotations. The one I highlighted was, binary stars are two stars. Right here. Again, he's ignoring the cherries he has picked. This states explicitly, binary stars are two stars orbiting around a common center of mass. Not planets. Planets, stars, not the same. It then goes over to 4/5, 80%. I've gone over that quite a bit as to how that number is probably due to an erroneous selection effect. Active research has shown that the multiplicity fraction of stars is far less than that. So, yeah. Also, that binary system, again, ignoring the cherries that he's picked. A binary system is simply one of which two stars orbit around a common center of mass. That is, that they are gravitationally bound to each other. The reason why I highlighted this is that later on, he is going to effectively tell his readers that gravity, he doesn't say that gravity doesn't exist. He just says that gravity is not important. That effectively, he's already told us that you can throw out Newton's laws. But he basically, later on, states explicitly that gravitation has nothing to do with how the solar system is functions. So, again, no idea. He then gives some nifty spirographs of looking at orbits of exoplanets, and in the what is that? The rotation frame of the barycentric rotation frame. Yeah, you get these really nice spirograph patterns. Really nifty, really, really confusing. At least to me. My solar system dynamics class was one of the hardest ones I've ever taken. It doesn't quite rank up there with cosmology, but boy, it really tested my math chops. Again, red dwarfs, which make up 70% of all stars. Oh, he got something right. That is in fact true. And he says that they were in the minority mostly because red dwarfs were not observed to have companions. Well, we have observed them to have companions, and the multiplicity fraction, as I've already stated a couple of times, is around the high 30s. So, yeah. So again, not only does I mentioned that he cherry picks his arguments, or cherry picks his data, but he also conflates or confuses. He compares apples to oranges and expects that to fly. So here we go. The nifty part. About our Sun-Mars binary system. The Sun, Mars, and the Earth, and their moons. Many stars don't even appear to shine with their own light. For instance, countless red and brown dwarfs are so dim that they remain completely invisible even to our largest telescopes. In fact, red dwarfs are the most common stars in the sky. Part of that statement is true. Yes, red dwarfs are and brown dwarfs are extremely low luminosity. Yes, they make up a very high fraction of the number of stars in the galaxy, as far as what the data is telling us. That does not mean they do not appear to shine under their own light. I guess maybe this is a semantic argument. I don't know. They're only invisible because of our technology. They're not invisible because they're invisible. They do shine light. We just can't see them because of their dim, which goes back to my whole brightness limited sample versus volume limited sample. A volume limited sample mitigates this effect, or is specifically geared to erase this bias. See my comments on the multiplicity fraction of M dwarfs. And so here it is. Here's one of his key justifications for his model, or not justifications, I suppose. You have the sun, and it's 2 moons. 2 moons. Venus and Mercury. Mars and its two moons, Phobos and Deimos. Words have meaning. If you want to change the meaning of words, then you need to do so in the text. What is your definition of moon? He kind of implies one later, and he basically states that a moon is anything that orbits anything else and is tied. No, actually, that would not apply to Venus and Mercury. He basically later on states that moons are those things that are tidally locked to the thing that they're orbiting, which is not how conventional science defines this. So, yeah. The simple definition of a moon is a natural object that is orbiting around a planet. That's our definition of it. So, Venus, by definition, is not a moon. It's a planet. A planet, part of the definition of a planet, is that it is a spherical object that orbits around the sun. More generally a star, but actually the specific definition is the sun. But I will not get into my diatribe on how that definition is bullshit. So here's the funnest part of this. Oh my god. All right. Here it is. As any amateur astronomer will know, Mars is a solid sphere reflecting light of the sun, but to the naked eye, it shines almost like a reddish-orange star. And so he puts up two things. One is a astrophotograph, and actually a rather poor one, of Mars, ground-based, I guess. But again, for a ground-based observation of Mars, that's actually not great. But there it is, actual picture. And he compares that to an artist's conception that he found on Wikipedia of a red dwarf. And he says that they look the same, therefore they are the same. I don't know what to do with that. I don't see how anyone would be able to find that to be a compelling argument. I'm trying not to be dismissive, but this stretches it just stretches my ability to take this seriously. Is that he's not even showing an image of a red star. We have those. We have images of Antares is blue. Of Betelgeuse, for example. Not a great image of Betelgeuse, but we do have an image of Betelgeuse, which is partially resolved from Hubble. He shows an artist's conception, and that isn't a great artist's conception. It's red dwarfs are typically far more active. They're far more spotted than that. But it is true that the spots are primarily bright instead of dark, although, yeah, reasons. You may now ask, how do we know about the existence of dwarf stars which are invisible even to our largest telescopes? He then talks about Cecil Domage's workings with a spectroscope. I don't think that exists. What he's talking about is a spectrometer or a spectrograph, or rather a spectrograph. And what is a spectrograph attached to? A telescope. So therefore, how do we know the existence of dwarf stars which are invisible even to our largest telescopes? If you're using a spectrograph, they are not invisible to the largest telescopes because you see them using a spectrograph. And incidentally, using a spectrograph is actually observationally expensive, because you lose light every time light hits glass. And a spectrograph uses a lot of glass in order to bounce things around, spread light out. And so you lose your ability to see really faint objects when looking at spectra. But he goes off and basically just yet again talks about how binary stars can be found in systems that look like single stars, but from a spectroscopic analysis, you can find them to be binaries. He is just killing this. Well, the horse is dead. He is just continuing to beat on it. I don't. Poor horse. I mean, this horse is just. It had a hard life, and now it's having a hard afterlife. Anyway, I quote, "Surely this has to be the most significant paradigm-changing astronomical epiphany of our modern age." What he's referring to is, today we know that the vast majority of our visible stars have one or more faint or invisible companions, and astronomers are discovering new binary systems at an ever-increasing rate. I don't know how many times he says this a lot, as I've already indicated, as I've already shown. Well, not I've indicated because I couldn't show it. As I've indicated, this is not the scientific consensus. And he seems to think that we know it is, and we are ignoring it because we are afraid that if we we state that the sun is in fact a single star, that it would be the anomaly within the galaxy, and therefore be hard to accept that it is in fact single. He then goes on to say, the implicit exceptionalism of the Copernican heliocentric theory, what with its companionless non-binary star and its gigantic 240 million year orbit. As I stated at the top of the stream, apples, oranges. All stars at the rough distance of the sun are going to have a 200 some odd million orbital period around the galactic center, superimposed onto, or rather the binary, if they are binaries, then their binary orbits will also have a 200 million year orbit. I do not understand what this is about. Here's another one, which I told myself to check out the reference. I apologize again. I just haven't had a lot of time. I have put some work into this, but I haven't had a lot of time to check this particular reference. It says our sun is a solitary star, all on its own, which makes it something of an oddball. Not really. But there's evidence to suggest that it did have a binary twin once upon a time. Recent research suggests that most, if not all, stars are born with a binary twin. We already knew the solar system is a total weirdo. The placement of planets appears out of whack compared to other systems and is missing the most common planet in the galaxy is Super Earth. I don't think that's accurate. I believe the most common planet that we have found so far is actually a Super Saturn, or Super Saturn, maybe a Super Neptune. I don't know if it's Super Earth, but again, the data is pretty specious on that at this point. Who knows? There are a lot of selection biases that need to be taken into account when you're starting to talk about the frequency of certain specific planets. But this is accurate in that the solar system does seem to be a weirdo from what we have seen. From the data that we currently have, our solar system seems to be only about 6%. So planetary systems that we have found, only 6% of them or so actually resemble the solar system in terms of having an Earth analog and a Jupiter analog. Howdy, Chris. All right. So, I didn't check this particular reference, but I did check into whether or not what papers I could find. It was a cursory check, but I checked out. I looked into papers that have been published talking about whether or not the sun is in binary, and the best I found was that, as I've stated before, the sun has thought to have been in basically in a cluster of stars, which is frequent. Stars are social. They get born in clusters, but they are not gravitationally bound clusters, and they will over time spread out and basically dissipate. There is this idea that maybe the sun did in fact have a binary companion. And one paper that I saw basically narrowed it down to a star HD 198 blah 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 blah. And it narrowed it down by saying that this star has the same, presumably came from the same prenatal cloud, or same cluster, and it has a composition very close to the sun. That's it. That's the evidence. Okay. Not compelling in my book, but sure. He goes on. Oh, here we go. He then, because it's the favorite punching bag, he goes on to say, we've all heard of dark matter, but are never told explicitly what it is. Apparently he has never talked to me. Because no one really knows. We do not have a consensus as to what dark matter actually is, but we have some ideas. One possibility is that it is normal matter. He says modern astrophysicists think of it as an elusive, invisible, imponderable stuff filling the universe and are desperately attempting to detect it, so far with no luck. No, not exactly. You would say modern astrophysicists as if that is all of us. That is not the case. It is the primary, that is where most of the funding is going. And you can argue that that's a mistake, but that is certainly not the only branch of research that people look into it. There are people who are trying to come up with an idea that dark matter is in fact actually ordinary matter, but they're running into some problems with that. And then there are other folks who think that they can come up with alternative theories to gravity, which don't have a dark matter issue. So, yeah. Let's see. Then he quotes a Wikipedia page on galaxy rotation curve. That is a piece of evidence suggesting that there is missing matter. Binary stars keep masquerading as black holes. I read this particular paper, binary stars masquerading as black holes. Two systems. Not the keep masquerading. It's two systems, and it's actually a rather, and again, I thank Mr. Shack because I did not know of that these types of systems existed. Certain phases of stellar evolution are astronomically very fast. And so the examples of them are not plentiful because we have a simple snapshot of what the universe looks like. Because of our very short time, because of the very short observations that we have and our lifespans and all that kind of good stuff, we are literally just seeing a snapshot. So we have to catch these stars as currently undergoing, or light travel time business, as they are undergoing that particular phase of evolution. In this case, the evolution is such that the companion, so the black hole was inferred to exist because we saw a star orbiting around a barycenter at a speed that would suggest a stellar companion, but no stellar companion could be optically identified. One of the reasons for this, one of the systems, it is these authors state, it is rotating so rapidly, it blurs out the spectral line enough that the spectrograph cannot see it. The luminosity, it blurs it out enough that the luminosity or the brightness drops below the detection limit of the spectrograph, which is actually pretty cool. And these may be the precursors to a type of white dwarf called a helium white dwarf, because these white dwarfs do not seem to have any observable hydrogen in their very, very thin veneer atmospheres. So actually, this potentially answers another question. What Mr. Shack tends to infer from this article is that, Yet again, there are binary stars out there that we are misclassifying. Sure. 2. Yeah. He goes on to state, in conclusion, currently available evidence suggests dark matter and black holes could be mere figments of the imagination engendered by our poor understanding of binary systems and optical tricks played by their complex interactions. Incidentally, black holes, for the baryonic folks, black holes are actually one of the leading contenders for what dark matter is. And this completely negates all of the other types of observations that we have to indicate that black holes exist. Supermassive black holes within other galaxies, for example. The most striking of which, for me, is the observations of our own galactic center, where you see stars whipping around a place that doesn't have anything, or at least that we have not been able to observe anything in that vicinity. And the mass required to make those stars zip around at those velocities is in the order of 4 million solar masses, or 4 million suns. And we see no light in that area? Seem to think that's a black hole to me. Then you've got accretion disk studies, you've got X-ray binaries. There is a multitude of evidence beyond this to indicate that black holes exist. So he then goes on, yet again, talks about the intersecting orbits of the Sun and Mars. Here he talks about the center of mass, or this is from the Australian page. I think it's lifted explicitly from there, where he has center of mass, he has the mass of one companion, the mass of the other, the focal point, basically the elliptical orbits, the focal points, yada, yada, yada. And then he basically alters it and puts in the Sun on one, puts in Mars on the other, puts in Mercury and Venus as the moons of the Sun, and then Phobos and Deimos as the moons of Mars, and represents it, and keeps the center of mass where it is, and basically by indication that the Earth is at the center of mass. Yeah, we'll get to that. He uses this word, which is, again, which to me strikes to some kind of spiritual or new agey kind of thinking. Harmonious. Okay, it's if you seem to think that this is harmonious, great. I don't. Here we go. Well, size is not everything. No one says that. Sorry, crude joke, but I had to be made. Now we're going to get into, now he addresses, obviously, why Mars? Why not Jupiter? I don't read all of this. This is a lot, but I'm going to read all of this in one go. There is no way of directly determining and comparing the weights of these two bodies, Jupiter and Mars. He says, let's not forget that Jupiter is considered a gas planet, while Mars is believed to be composed of mostly rock and iron. There's no way of directly determining and comparing the weight of these two bodies, but I trust we can all agree that the density, interestingly enough, hence the relative weight of iron and rock, are several orders of magnitude greater than any gas existing in nature. I don't know what density has to do with anything, because by his own diagram, it's the center of mass, not the center of density. And no, they are not orders of magnitude larger. The Earth is, Mars actually has a density of about 3 point some odd, whereas whereas Jupiter has a density of 0.9 grams per cubic centimeter. So, one order of magnitude? Maybe? Definitely less than 10 times, so I don't know what he's talking about there. Furthermore, aren't we told that the sun itself is composed of hydrogen, 70%, helium, 28%, and a negligible 2% of other denser elements, metals, as we astronomers like to call them? Seen in this light, could Mars have a mass similar to that of the sun in spite of their David and Goliath difference in diameter? While this type of argument will appear to the adherents of Newton's gravitational laws, it should be stated for the record that my research for the TYCHOS model has from day one left Newtonian and Einsteinian physics at the door, so to speak. It has instead focused on the all-important, empirically testable, repeatable, and verifiable observational data gathered over the centuries by our world's most rigorous observational astronomers. To wit, seems to be a popular phrase to him, no physical/astrophysical theorems of our solar system can be formulated without having first correctly determined its geometric configuration. Doing so would be tantamount to putting the proverbial cart in front of the horse. At least in that last statement, we haven't done that, so I don't know why he seems to think that we have. So here, he explicitly states that in his model, gravity doesn't matter. He's not saying that, he doesn't seem to be saying that gravity doesn't exist, isn't a thing. It just doesn't matter when it comes to the configuration of the solar system. Yet, by his own definitions of binary stars, they are gravitationally bound. The whole definition of what a binary star is, as he clearly shows here, is two things orbiting around a common center of mass. Why? Because of gravity. You can't put that to the door. If that is the basis of what you are describing as a binary, then you can't just simply erase gravity, or say that it's not important, rather, and move on. At the very least, you got to replace it with something. I suspect it could be that he does so later, because I've only, as I've stated, only looked at the first 3 chapters of this. But I don't think so, because he states, he is focused on the all-important, empirically testable, repeatable, and verifiable observational data gathered over the centuries by our world's most rigorous observational astronomers. Basically geometry. He is relying strictly on geometric arguments, which when he says that he is basing this on empirically tested, repeatable, verifiable observational data gathered by astronomers, he isn't. Because that data supports the NEAS model of the solar system. A model which states that the sun was formed from a prenatal cloud. When that cloud collapsed, a vast majority of that mass went into the formation of a protostar. The rest, the large fraction of the remaining gas went into a disk. From that disk, planets coalesced. And within that, when they coalesced, the gravitational interactions with the planets caused planetary migration. That is the elevator pitch of the NEAS model of the solar system. This is backed up by verifiable, empirically testable, repeatable observational data. This is a lie. Either not knowingly or not. Mars is the only body of our solar system that can transit on both sides of the Earth in relation to the Sun, and whose furthest to closest transit from Earth exhibit a whopping 7-to-1 ratio with a mean apogee of blah and a mean perigee of blah. This is a strong indication that Mars, and no other body in our solar system, is the Sun's binary companion. Figure 3.6 makes this clear. Figure 3.6. It does not make it clear to me, because Jupiter's not in this. He also does not give a physical justification for why those particular numbers and a 7-to-1 ratio eliminate Jupiter as a possibility. He might in other chapters, but he doesn't here. Well, he says, as we shall see in following chapters, there are many good reasons to think that Mars and no other body in our solar system is the Sun's binary companion. So, stay tuned. All right. So, moving on. This is where I got most frustrated. Once the main source of error has been removed from Tycho Brahe's accurate recording of the entire cycles of planetary motion, I believe this is Mr. Shack's emphasis, the most outstanding divergence between theory and observation was in the case of Mars. It is especially important to note that Brahe improved the accuracy of parameters and observations at the same time as to obtain for the first time in history a clear discrepancy between the place of a planet and its predicted position by circular theories. In the past, such happenings had been swamped by other errors and uncertainties. Using Brahe's results, Kepler could prove in this one case, but in no other, that circular theory must break down. This is exactly the reason why Kepler ellipses could not be suggested before the work of Brahe, and indeed why Kepler had to develop his theories on the basis of the study of Mars. Okay. So for those of you who aren't here, he has been using the term Copernican model from the get-go. Except in the preface, where a subsection heading was something, the carousel nature or something of those lines of the Copernican/Keplerian model. I stated at that point that the Copernican and Keplerian model share one thing in common, and that is the sun is at its center. Outside of that, they are fundamentally different systems. He ignores Kepler for all of this. I can also tell you from chapter 31 that he states that the TYCHOS system that he develops holds to the Aristotelian philosophy that planets move in perfect circles at uniform velocities. Why is this important? And this is the most egregious form of cherry picking that I've seen in this entire book. Which is Kepler. Who is Johannes Kepler? Johannes Kepler was not an astronomer. He was a mathematician. In today's parlance, he would be considered a postdoctoral researcher. What is usually done is that an established astronomer will hire a recent graduate, a recent PhD graduate, in a research strictly position. These usually last about 2, maybe 3 years if you're lucky. And their job is to essentially analyze or look at a specific problem within a larger contextual issue. That's what Kepler was hired to do, is that Tycho had a model that he created. Tycho was also a mathematician, but not as good a one as Kepler was, because if that were the case, he wouldn't have had to hire Kepler. Tycho came up with this model that we've just discussed. The idea that the Earth is the center of everything, and the sun revolves around the Earth, the moon revolves around the Earth, and then everything else revolves around the sun. Tycho couldn't get it to work because of Tycho's own observations. So he handed it off to Kepler. And Tycho used the idea of perfect circles and uniform motion. Oh, hold on. Chris Durham asks, how many billions of years does it take from big mess of dust and gas to the birth of a solar system? We believe it's somewhere in the range of 10 to 15 million years. PhD Tony says, we can put the twin star hypothesis in the non-falsified basket. Not falsified basket. Stephanie says, y'all want to hear something funny? Just asked my 10-year-old grandkid about the globe. He is adamant we are spinning on a globe. No logical thinking required. He's a 10-year-old. You expect logical thinking from a 10-year-old? I mean, aside from globe, flat, whatever, you are attributing logical thinking to a 10-year-old. Well, that's news to me. Anyway, Chris, that was, yeah, right now we think it's about 10 to 15 million years, although it might be a little longer. So Kepler, anyway. So Tycho used circular orbits, constant motion, couldn't get it to work. Tycho's observations were said to have a precision of 1 arc minute, meaning that he could tell the difference between 2 separate positions down to a level of 1 arc minute. What is an arc minute? Well, 1 arc minute is 1/60th of a degree. Or, take the full moon, cut it into 30 equal slices. That slice is 1 arc minute. It's incredibly precise for someone who did not ever use a telescope. It is amazing. Tycho is my guy. I loves me some Tycho. And what Kepler found, or rather what Tycho found, was that given his model, there was a discrepancy in Mars's orbit of 8 arc minutes. This is 8 times the precision of Tycho's observations. So you have two options here. You can either say that Tycho's precision was actually not 1 arc minute, was actually larger, and so the two theories can actually be rectified, at least, or the model can be rectified with observations, at least to some order. Or the model cannot be rectified with the observational evidence. The observational evidence says that Tycho's model, the neo-Tychonic system that Mr. Shack is putting into practice, does not work based on empirical, verifiable data. This is mind-boggling to me. He does not mention this in the book. Or he does not mention this in his book. Kepler essentially, and this is what's so egregious about not mentioning Kepler, is that Kepler himself was the first person to falsify the neo-Tychonic system that he is holding to. Now, can you come up with a neo-Tychonic system that uses ellipses that better fits observations? Maybe. I would love to see one. But we know for an absolute certainty that uniform motion and constant velocity, or uniform motion and circular orbits do not work. Hence, why Kepler had to develop his empirical laws of planetary motion. And again, not an astronomer, he's a mathematician. He just had data, and he fit it to ellipses. Well, in this case, he fit Mars to an ellipse, and he saw certain relationships within it. Now to the claim that Kepler had to develop his theories basis on the study of Mars. That is a selection effect. Why? Mercury is incredibly difficult to observe because it is so close to the sun. I don't know if Tycho has any observations of... Actually, I am not aware of any of Tycho's observations beyond Mars. But getting a full orbit of Mercury would be extremely difficult to do. Would take an extremely long time because you'd have huge gaps in your data, in your time cadence, in your time series, because the sun's in the way. You literally cannot see Mercury. Venus suffers from this as well to a lesser degree. getting a full orbit of Venus, an accurate full orbit of Venus, would be difficult. Mars, not so much. You can get Mars, a complete orbit of Mars, within a couple, 3 years, or longer if you want to be more precise about it. But you cannot do this with Jupiter because its orbital period is too long. Off the top of my head, let's see. Mars is someone who is very better at math than I am, who does math better than me. Mars has a orbital period, or has a distance of 1.5 AU. Jupiter has a distance of 5 AU. T squared equals A cubed. You can figure out the relationship between how much longer the Jovian orbit is, the Jovian year is to Mars. I want to say that it's about it's larger than 5 times. It's larger than 5 times long. The Jovian year is far longer than the Martian year. So in order to collect the same amount of data in terms of coverage of the entire orbit, would take far longer for Jupiter and even longer for Saturn than it would for Mars. So Mars just happens to fit ideally within the... Howdy, Indy Tiger. Mars fits ideally within the fact that it does not have nearly the same problem as Venus and Mars does, or Venus and Mercury does, in the fact that they're too close to the sun. But it also has the benefit that its orbital period around the sun is reasonably short, given a human lifespan. Georg Johannes Kepler was an astronomer, mathematician, natural philosopher. Due to the fact that he had to study the 7 arts later on, he studied then the laws. Maybe it's a quibble of mine, but I wouldn't call him an astronomer because he never took observations of the stars himself. He simply analyzed data and fit mathematical models to them, although I guess you could say that he was a theoretical astrophysicist at that point. But in the conventional sense, he doesn't really measure up to earning the title of astronomer. That is not to say that I am discrediting his importance to the field of astronomy in any way whatsoever. Kepler's contributions to astronomy cannot be understated. You may have remembered that before he talked about there is no way to measure the mass of Mars and Jupiter. Well, that is true if you conveniently forget that Kepler existed and you put Newtonian mechanics to the door. Because one of the just fantastic things, fantastic demonstration of how science operates is the interplay between Kepler's laws and Newton's law of gravitation. Kepler came up with these empirical laws of planetary motion. He simply looked at data and he fit a mathematical model to it, specifically an ellipse of a certain eccentricity. And from that, there were certain implications that came out, such as equal areas and equal times. The speed of the planet is faster near the sun, slower near when it's away from the sun. T squared equals A cubed, or at least the ratios of such, yada yada. Jovian year is 12 Earth years, so yes, significantly longer than the Martian year. Newton needed something to test his law of gravitation, and he said, "Hey, I've got these empirical laws that Kepler came up with. If I make the assumption, or assertion rather, that the physical reason for why planets orbit the sun is gravity, then given my law of gravitation, I should be able to derive those empirical laws independently. Simply using the theory of gravity that he had developed, he should be able to arrive at the same laws that Kepler came to simply by looking at Mars." And he did. With one notable caveat. The third law, the harmonic law. Kepler could only write it as a ratio. He stated that the period of a planet with respect to another planet squared was equal to the ratio of one planet's semi-major axis, effectively radius, size, the ratio of one planet's semi-major axis to another planet's semi-major axis cubed. He could not absolutely state t squared equals a cubed unless you assumed certain units, where the unit of time is an Earth year and the unit of distance is an astronomical unit, or the average distance between the Earth and the Sun. Essentially, you would use Earth as your reference point, and basically the corresponding values of T and A, or P and A, are 1. That is the only way that you can get an absolute value. Everything else is relational. Newton came around, using his law of gravitation. He found out that there was, when you do the proportionality, when you do that ratio, there is a constant factor that goes away, that essentially gets canceled out, and within that constant is the mass of the system. The actual formula is t squared equals, I'm going to embarrass myself, 2 pi a cubed, 4 pi a cubed over g times the sum of the masses, where the masses are the mass of the sun and the mass of the Earth or planet. Now you have a way, if you know the masses of the objects, you have a way of absolutely determining the period of an object. Say you have an asteroid, you know its mass somehow, or rather, you neglect its mass. I'll get into that in a sec. You know its mass. You determine its you know what its period is somehow. You don't have a lot of data, but you know that it came back to the same point in 70 years. Using that formula, you now know its semi-major axis. You now know how big its orbit is. Now, in actual practice, what is usually done is the mass of the asteroid is negligible in terms of the mass of the sun, so you basically just can ignore it. In terms of the mass of Jupiter, I do this with undergraduate students. You look at the Galilean moons, you look at their orbits and periods, and you can determine the mass of Jupiter using Newton's revision of Kepler's third law. Mars, you can do the same thing with Phobos and Deimos. You can do the same thing with satellites that you put around them. So yes, we can, in fact, actually determine the masses of celestial objects thanks to Kepler, but most importantly, thanks to Newton. So, fishing, nice. Thank you, Stephanie, for being here. So the fact that he ignores Kepler entirely is just egregious. For someone who claims that he is following basically the observations of things, and he's referencing these papers and these websites and so forth, to do this, again, I have to say that this is an obvious deception, that he knows that this is true, or that this is what the science is, and he is simply ignoring it. And he doesn't even have the decency to say that it's ludicrous, to say that it's obviously it can't be right because the idea of things moving in an ellipse is just laughable. He doesn't even include that. He just doesn't include it at all, except for sort of alluding to it there. He then puts in, do we live in a binary system? Again, he is beating the shit out of this horse. And this looks like a Quora, something from Quora, which I don't, some kind of online ask a question, get an answer. And he gets an answer from a systems analyst and programmer. Not an astronomer, not a physicist, but a systems analyst and programmer, who claims the distribution of the angular momentum of the sun is wrong, the solar precession equations don't accurately explain observed precession data, the Kuiper cliff at 50 AU shouldn't be there, and on and on. Up to 80% of observable stars are binaries. I've already covered that. I haven't verified any of this. Some of these are new to me. The angular the angular momentum of the sun is wrong. Okay, I will take your word on that, and we'll look that up, look into it longer. I knew about the Kuiper Belt Cliff. The Kuiper Belt Cliff is that we do not detect objects beyond 50 AU. Essentially, there is a sharp cutoff, relatively sharp cutoff, between objects and then empty space. That could be a selection effect. It could be that the further you go out, these aren't stars. These are things that are reflecting light. The further you go out, inverse square law, further you go out, the less light there is to reflect. It also could be that the objects that are further out become preferentially smaller. Who knows? It is very plausible that there is a selection effect creating the Kuiper cliff, and who knows? They may have somewhat solved it. I doubt it. But in any event, if all of these things are true, except for the last one, which I have described as not being true, what that would indicate is that the sun is in a wide companion binary system, like being in a binary companion system with Alpha Centauri. It would not indicate a close binary system, which would be the Mars-Sun system. So this does not support what he thinks it supports. He then goes into comparing the moons of Mars and Saturn's. He states that the reason why Kepler apparently did not, Brahe, Newton, and Kepler did not think of this system is that they were completely unaware of the moons of Mars. That's a non sequitur because they don't matter in terms of the orbit of Mars around the sun. He then states, each year Mercury revolves 3.13 times around the sun, whereas each day Phobos revolves 1.3 times Mars. Basically, he is stating that Mars and that Phobos and Deimos are tidally locked to Mars, much like the moon is tidally locked to the Earth. This is a very common phenomenon within the solar system. Incidentally, it should be noted that the reason why tidal locking exists is because of, you guessed it, gravity. So he is basically, one of his definitions essentially is, or one of his points, his arguments is that because Mercury and Venus show some kind of tidal locking to the sun, they are in fact moons because all of the other moons are tidally locked, which in and itself is not true. Most of the major moons are locked, but I don't believe Triton is for Neptune, and also a number of the captured moons from Jupiter and Saturn are also not tidally locked. I mention this because Phobos and Deimos, which are tidally locked, are captured moons. I bring this up, and I'm really not going to get into this yet, but one of the major problems that I have with this text, or with this model, which I have with many models like it, is that it tells me nothing about how it formed, how it physically came into existence. And that is crucial when trying to compare Phobos and Deimos to any other moon, like the moon or the Galilean moons, certainly if you want to try to compare them to Mars and Venus. He then states that the sun rotates on its axis approximately 27.3 days. This is the so-called Carrington number. This is accurate enough. The Carrington, the reason for this is because the sun is a differential rotator. Depending on what latitude you are, the rotational period, the day of the sun is going to be pretty different. Near the equator, it's around 24 days. Near the pole, it's around 30 days. By some averaging, you can average the sun's rotation to be 27.3 days. He then goes off later on and basically states that that this is somehow equivalent or to the sidereal period of the moon. The sidereal period of the moon is approximately 27.3 days. It is 0.3 something something. The Carrington period is 0.2 something something. So there's rounding involved. I haven't gotten to how he physically justifies that. He asks, you must now justly ask yourself, down here, why are Mercury and Venus the only planets of our solar system with no moons of their own? And he quotes someone from NASA. Or he quotes an astronomer. Most likely, they are too close to the sun. Any moon with too great a distance from these planets would be in an unstable orbit and would be captured by the sun. If they were too close to these planets, they would be destroyed by tidally gravitational forces. The zones where moons around these planets could be stable over billions of years is probably so narrow that nobody was ever captured into orbit or created in situ when the planets first accreted. It's not a great explanation, but on the face of things, it's accurate enough. He, of course, rejects this as saying it is timid and tentative. So, why does Mars? The better question is, why does Mars have moons? Why does the Earth have a moon? Well, why does Mars have a moon? Have moons? They're captured asteroids. Mars did not form with moons. It gravitationally grabbed asteroids that passed too close to it. It's happenstance. We don't know, or at least I don't know, I'm sure someone has figured it out, how long Phobos and Deimos have been around Mars. I sincerely doubt it's been around for billions of years. They are captured asteroids. Again, I hate to use the word coincidence, but they didn't form with Mars. They are not physically associated in that way. Why does the Earth have a moon? Well, impact. The best explanation we have is that an object the size of Mars, in the very early stages of the formation of the Earth, when the Earth was still molten and somewhat differentiated, Thera, I think it's called, comes in, slams into the Earth at an oblique angle with enough energy that it plows away material away from the mantle region of the Earth, and leaves behind some of itself, and that material that got plowed out goes into orbit around the Earth, and from that material, the moon then coalesces. This idea of impact formation is not ludicrous. We see evidence of large impacts on other bodies in the solar system all over the place. In the early stages of the universe, this is a common occurrence. Things were slamming into each other with high rates of energy all over the place, hence why the moon is cratered. This just happened to be an exceptional case of an impact between two relatively comparable mass bodies where the two bodies didn't blow each other to bits. Venus has an orbital period, is retrograde in its orbital period, or in its rotational period. Its rotational axis is flipped in relation to the Earth. we rotate in different directions. The best explanation we've come up with there is, again, an impact. That it basically got knocked its ass over tea kettle. That it just got flipped. Now, why is there no moon? I'm not entirely certain. I would assume that the dynamics of the impact were not did not produce one. That the material of that was plowed out was either not enough to form a moon, or, as this person implies, the gravitational influence of the sun, which would be greater in that system, disrupted any sort of moon forming in situ or in that location. And the material that did get plowed out eventually went somewhere, either fell into Venus or flew out elsewhere. Mercury has an oversized core. Its core is, in relation to its body as a fraction, is significantly larger than the iron cores of Venus and the Earth. Why? Impact is the best explanation we have for this. For some reason, Mercury shows evidence of a massive and very rapid contraction. It just shrank for reasons which we don't clearly understand. One possibility is that it got smacked, that something smacked into it and carved out enough of it that forced this contraction. I really do need to look into it, but essentially, again, an impact would explain Mars's analogous or peculiarities. So, might be Theia. Thanks. I saw a reference to, it wasn't a journal article, it was a Pop Science article that said that geophysicists had seemed, or confident they have found Theia. The object within, like the remnant of the object is still somewhat cohesive, or somewhat still together, intact, and is orbit around the core. I haven't had time to really look into it. But it's not a question of why Mercury and Venus don't have moons. A better question is, why do Earth and Mars have them? Because from a formation standpoint, we would not expect such small mass or such low mass objects to form an accretion disk around themselves from which a moon could form, which is what we believe happens for the major moons of Jupiter and Saturn. This is getting into 3 hours, so which I guess is appropriate for 3 chapters. He goes into, again, some numerology. Venus's diameter is 2.5 times larger than Mercury's diameter. Phobos's orbital diameter is 2.5 times larger than Phobos's diameter. Phobos's diameter is 1.8 times larger than Deimos's diameter. Venus's orbital diameter is 1.8 times larger than Mercury's orbital diameter. Is that true? That would be 0.7 divided by 0.4. Is that 1.8? I don't know. I can calculate it. So again, he's pointing to these resonances, or these similarities, as being some kind of indicative nature. Why Venus doesn't have a moon is a mystery for scientists to solve. I've basically given you the explanation for why it doesn't. Yes, it is a mystery, but it's not a paradigm shifting definition. Oh, I think I missed this. No, I didn't. Definition of a moon. Based on the above, the characteristics that set moons apart from planets may be summarized thus. May be summarized? Are you not certain? No moons have satellites of their own, since they are moons themselves. Okay? Moons rotate exceptionally slowly around their own axes compared to all other celestial bodies. that's subjective. Io rotates very quickly in comparison to, say, the moon, because it rotates once every couple days. So I don't know what to tell you on that one. Moons always show the same face of their host star or planet. The astronomy jargon, they say they are tidally locked. That's not jargon exactly. That is a physical phenomenon based on gravity, which you, sir, have decided to leave at the door for reasons. I need to check on Triton, but I don't think Triton is tidally locked, but he is right. All of the major moons of the solar system are, in fact, tidally locked, but the captured asteroids surrounding Jupiter and Saturn, not so much. So, rotational resonances between Mercury and Venus. So here's another egregious form of cherry picking. There are two types of rotational periods, synodic and sidereal. The difference between the two is that a synodic period is in relation to the sun, and the sidereal period is in relation to the star, or the stars. We can effectively say that the stars represent a fixed reference system in order to calculate a rotational period. So the Earth, for example, has a sidereal period of 23 hours and 56 minutes. It has a synodic period of 24 hours. Thereabouts. I don't think it's exactly because, equation of time and all that. And also the orbital period actually changes slightly due to interior specifications. But putting that aside, sidereal period, 23 hours, 56 minutes. Synodic period is 24 hours. Why are the two things different? It's because of the Earth's orbital motion. It takes a little bit of time for the Earth to rotate such that the moon or that the sun comes back into a noon position from the previous noon position. So when you look at the difference between a sidereal and a synodic period, the difference is caused by orbital motion of one form or another. Here he is equating Mercury's rotation to Venus's rotation. And he states that Venus's rotation is exactly twice as long as Mercury's rotation. I haven't verified the specific numbers that he's using to that kind of precision because he does use the word exactly. But 58 days, that's the sidereal period, or sidereal period of Mercury. 116 days, that's the synodic period of Mercury, or of Venus. The sidereal period of Venus is something like 240 days. He is not comparing apples to apples. He is comparing apples to oranges and looking for, basically grasping for any kind of connection that he can find, which is disingenuous. And he basically plays this game of trying to find these, I would say resonances, but they're not exactly resonances within the solar system, within these planets, to somehow justify his arguments that Mercury and Venus would in fact be moons of Saturn. Now, it is true that Mercury does have a resonance. It is in a 3-to-2 orbit spin resonance. Resonances, basically if you take one period in relation to another, you will find that they are usually integer values of each other. So, for example, Mercury's orbital period is 1.5 times longer than its daily period, its rotational period. Its rotational period is roughly 55 days. Its orbital period is roughly 88 days. That is due to the gravitational influence of Mercury. The fact that the moons are tidally locked, gravitational interaction, which again he puts to the side. So that's basically it. Those are the first three chapters. The fourth chapter is introducing the TYCHOS model. Titan is tidally locked. Triton is the one Triton is the major moon of Neptune. I don't know whether or not it's... I haven't looked to see if it's tidally locked or not. Well, screw it. Let me see if it is. It's... that one? Alright, hold on. There we go. Is Triton tidally locked? Yes. Yes, it is. Okay. Oh, damn. Triton is way closer than I thought it was. I thought Triton was much further away. But anyway, so that's it. That is my review. And let me see. I actually don't know if I can kill this stream. That's fun. Oh, there it is. Okay, good. Yeah, with the Google page that I can't show you because of, OBS. All right. With that, I will bid you all adieu. Thank you for watching and sticking, particularly those who've stuck around and watched this for 3 hours. I very much appreciate the support. I am Professor Perks, PhD, and I make content on astronomy, science, skepticism, and mental health. If you like this sort of content, please like, share, and subscribe, and hit that bell for notifications, because as I like to say, I am a chaotic son of a bitch, and I post irregularly. So if you would like to keep updated with when I go live like this, please hit that bell for notifications. If you would like to help support the public outreach events that we do here at the observatory or the observatory itself, please consider becoming a patron of mine. My current patrons are Dora Naku, Sci-Fi Indie Reviews, and most importantly to me, Judy Bassett. Through their donations, I'm able to buy things that are small, like power strips, lights, that sort of thing, or things that are large, like a planetary camera. If you'd like to help me financially, please consider becoming a channel member. All of that money goes into my grubby hands, and hopefully that money will motivate me to really make this more of a sideline business and possibly even a secondary career. Channel members, I haven't looked recently, but my channel members, I believe, I have 2 of them, Judy Bassett and Bellywood. Eventually, I will have an outro where I acknowledge all of these folks. But anyway, so that's my pitch. And with that all being said, I am going to go. And I hope you all have a good day. I will be coming back to this. I will be reviewing the next 3 chapters, which are introducing the TYCHOS model, Mars, the, quote, key that Kepler never found, and is Sirius the twin of our solar system? So look forward to that. All right. Peace out and clear skies.